So in my last video, actually the recording stopped abruptly. By mistake, I clicked on something instead of pause, I clicked on stop. So in this particular tutorial or session, I'll be covering how to install a multi-node HDP cluster on AWS. So basically, you need to have an AWS account. You need to log into your AWS console, and then in the services, you can go to, in the compute, we need to go to EC2 services. So basically, we are going to create a 3-node cluster. Right now, I don't have any running instances here. So I need to launch a new instance. So basically, I'm going to create one new node, and then I'm going to prepare that node for HDP installation with Ambari. Ambari is a very good cluster management tool with a very good web UI. So to prepare that, I'm going to start my launch instance. Here I'm going to choose one of the OS, like I think for me, so we can take Red Hat, or we can take any other Ubuntu or any other operating system. So I'm going to take this Red Hat CentOS based operating system, 64-bit. So I'm going to choose now the size of this instance I need to choose. So let me choose, so basically for every instance, there are different pricing. But I'm going to choose, say, M4.xlarge, which has got 2 virtual CPUs, 8 GB RAM, and it's having a moderate bandwidth network performance. All right. I'll go next. I'll first create one node with this, and I'm going to go with the default options like shared instance instead of dedicated one, because additional charges apply for dedicated tenancy. So let's go with multi-tenancy mode. This is the storage which I want. So basically, being a big data cluster, say I'm going to have each node with 3 nodes. So though I may not have such a big data initially to process or store, but I would like to keep it, say, 40 GB. This sizing we need to do based upon our daily data load, and number of nodes also are decided by that. But I'll do one thing. I'll just, okay, tag security group. I'll go with so I'll just give a name here. My HDP cluster. All right. So configure security group. So say use any of them. So I've got many security groups here, so I can choose any of them. I can even copy one of them to new, but I would like to show like what all configurations are needed. So or maybe I can choose existing one, and I can show what changes we need to make to the existing security group. So let me take this one. All right. So this security group has got 8080 port open to all and all traffic open to all. It's not a good idea, but let's start with this, and later I would like to restrict it to certain IPs. Now I'll say review and launch. All right, so this is my configuration. Now this SSH, it is given to a certain IP. I am not sure. All right, so we can edit this group later. Storage, I had chosen 40 GB. There are different type of volumes. Let me launch it. So it will ask you whether to create a new key pair or existing key pair. I have an existing key pair. which I created some time back during my last video session. You can see. So it says, do you have access to the key? Yes, I do have access to my key. So my key I have kept stored here, AWS SDP cluster PAM file. I'm going to choose this and launch this instance. So this instance is now launching. So I'm going to prepare this instance. So what I'm going to do is I'm going to take this instance public IP, let it launch first. So it will take some time for initializing, setting up things and launching, and it's now running, and status checks are initializing. So I'm going to store, keep some of the data from here. For example, it's public IP. It's internal IP. I'm going to copy, and so it's not a cluster. I'll call it HDP, say main node or base node or whatever we can call it. I'm going to copy this. So the private DNS name, I'm going to keep it and say call main node. And then we are going to have certain services here. So two more nodes we will be creating. But first I'm going to prepare this node for HDP installation. All right. So basically we are installing a cluster. We need to do certain things. There are certain prerequisites. For example, all these nodes should be able to talk to each other because when Ambari is also used, and as we know, Hadoop architecture is basically a client-server based architecture. There are many daemon processes running. So every client needs to talk to a server, as well as there are heartbeats shared between different clients, like between name node, data node. Same way with between Ambari agents and Ambari server. So I'm going to put some things there in this node, and then I'm going to create an AMI image, Amazon machine image, and then I'm going to spin off two more nodes from this. I'm going to switch off the IP tables on this node. I'm going to also install and run one NTP service on this node, which is like so that time is synchronized across the network. So let's do it. All right. So let me take my public IP, and I'm going to go to putty here, HDP cluster load. I'm going to say replace this and save it. So basically, I'm going to put this IP here. I'm going to see in auth if I have selected my PPK file, which is basically created by puttygen using PEM file, and I'm going to go here and I'm going to or maybe I can rename it. It's not the whole cluster. I'll call it HDP main node so that we are clear about it. All right. So save. So HDP main node, this HDP cluster, let me delete. So this HDP main node I'm going to load and I'm going to open. So it will ask whether I trust this key. So I trust this. For a particular different OS instances in EC2, you have different default users. For Ubuntu, it's Ubuntu. For CentOS, I think CentOS is also there. For RHEL, I think EC2 user will be the user. Okay, so it's authenticating with the public key available on this instance. All right, so this is my present working directory. Now what I'm going to do is, first I'm going to create an NTP service here and then IP table service and switch that off. So I'll use everything with sudo chk config ntpd. So I'm going to check whether ntpd service is on. So basically ntpd on. So no such file or directory. So basically ntpd service does not exist. We need to install it. Sudo yum install ntp. So I'm going to install ntp service on this instance. So we are installing it. So it will ask for something installed size. I say yes. All right, so ntpd is installed. After this, I'm going to check this thing again. Sudo chk config ntpd on. So it created a symlink of ntpd service here, and I'm going to use systemctl start ntpd. Let's see. Everything with a sudo will be better. Start ntpd. So ntpd service has started. All right, so all right, so now I would like to check the status of ntpd service. So we can see ntpd service is active and running here. So these steps we need to remember. We installed ntpd service. Afterwards, I started ntpd service and chk config on, and then I checked the status. So simply ntpd service is started. Now, second thing I need to check if IP table service is there. So sudo chk config IP tables off. So I'm going to do that, but again IP table service is not there, so I'm going to install that sudo yum. I say -y means with yes if any question is asked. Sudo yum -y install IP tables services. So it's installing complete. All right, so IP table service is also installed. Now after installing IP table service, first I'm going to do is again start these IP tables. Okay, so this service I'm going to start. So the service is started. Now if I check the status of IP table service, so service is active. Next thing I'm going to do is I'm going to save IP tables service with firewall rules. All right, so I'm saving firewall rules to IP table service, and then I'm going to basically put my IP tables off. All right, so this is the command. Now again, I'm going to check the status of my IP tables. So it is still active. So one moment, I need to stop my IP table services. So here, all right, so this is inactive, dead. All right, so now what we are going to do is we need to copy our PEM file to the instance for creating a passwordless SSH between nodes. All right, so we can see here there is a directory called .ssh which has got some authorized keys. Okay, so if I do a cat of this authorized keys, sorry, sorry. All right, so this is my authorized key, okay, for AWS SDP cluster. So I'm going to provide that AWS SDP cluster PEM file here so that there could be a passwordless SSH from all other nodes to this node with this particular AWS SSH key. So where do we move this file? First thing I'll do is I'll basically, sorry, there is some problem in my AC, I don't know. All right. So I'm going to use, because I'm using Windows, so I'm going to use a tool called WinSCP. That's very good for moving this file from Windows to a Linux instance. You can use SCP to SCP. You can use SCP. So what I'm going to do is, so I have my host name here. I'm going to, again, just like SSH, I'm going to take this, put my host name here. I need to provide my username, and I'm going to select authentication. That is my private key file, and I'm going to log in. So it's searching for host. It says, it gives server's key details and authenticating. All right, so basically I will be moving my key from particular folder where I kept it. Site training, AWS, bloody hell. One moment, please. This AC is giving some, air conditioning has got some problem. All right, sorry for interruption, but I'm going to move ahead. So I'm going to copy this PM file from here to here. So it's transferred pretty fast, depends upon the connection we have. After that, I'll just close it. I don't want to, right now I don't have to copy anything, so I will close this connection. And I can see here, this file has been moved here. So what I'm going to do is I'm going to move this file from this location to .ssh directory, and under that id_rsa. So I'm going to basically kind of renaming this file in, as the name will be id_rsa, which is recognized. So all right, so now this file is not here anymore, but if we do ls, so inside that there are two files, authorized keys and id_rsa. All right, so this is pretty much what we need to do right now to prepare this cluster. Now the next step, what I'm going to do is, as I moved my key file here, there is a very good tutorial here. After moving the key file, we'll be provisioning other nodes. So what I'm going to do is I'm going to first create I'm going to create an image of this particular node. All right, so what I'm going to do is sorry, so I'm going to move here. I go here and I create an AWS image of this node. I call it something like HDP base config or HDP base node. All right, so SDP node config. So it's my image, SDP Hadoop node configuration. All right, so I'll just call it. this, and it's got 40 GB. I can add more volume also for other nodes, but let's uh, stick to 40 GB right now and create an image. One moment, I think I forgot to. Okay, there is some problem which is there. I think no reboot. I forgot to tell because this image will be rebooting. I should have selected the no reboot option. No problem. We'll create another image. I can delete the images as well. So we can deregister this one and register a new EMI. One moment. So we'll be deregistering this one, or I'll create another one. So I'm going to choose image, create image. So this no reboot option, if you see what it says, when enabled, Amazon EC2 does not shut down the instance before creating the image. When this option is used, files into create image cannot be guaranteed. All right. So when enabled, it does not shut down the instance. All right, before creating the image. Now the problem is. Might have rebooted my other instance, so that's why this problem happened, but nevertheless it's rebooting, so let it reboot. All right, so let it reboot this instance. How do we come to know that it's rebooted? Right now alarms are not configured, but we can configure alarms. So what I'm going to do is I'm just going to try SSHing into it with putty. I load this, open this up. Yes, it seems to have been rebooted. All right, or else it won't allow me to connect. So internal IP is 175.175. All right. Okay. So now our image is already there. There is an AMI image created which is available. There is some AMI name and there is name for this, but let's just launch. Before launching this, do we need to do something else? No, I'm going to give the same security group here. One thing I need to check, I think wizard 1, so same security group I'll give. Same size I'm going to give, so I'm going to give m4.large to this. So it's going to be the same size. How many instances do we need? So we have a 3-node cluster, so one is already there, 2 more I'm creating. Everything else is same. Adding storage, no. 40 GB is good. All right, free tier customer, so will charge me something for 10 GB more. I could have taken 30 GB. That's would have been all right, but it's okay. I'm not going to add any more tags here. I'm going to configure a security group. I'll select an existing one and I'll take launch wizard 1, whichever was available earlier, and review and launch. And it's asking me to review with certain things that we can improve our security. It's open to the world right now. Yes, they're right. So I'm going to do that in a couple of minutes more. I have to choose the same key for this. All right. So I'm going to choose the same key for this. and just so more instances are being launched right now. So we got 3 running instances. That's what I was thinking, why there is only one. So 2 more are being launched now. I'm going to give some name to it. So I'm going to call it HTTP node 2 and HTTP node 3. All right. And then I'm going to store these things like I need their internal IPs or internal private DNS for future use for installing services through Ambari. I'm going to take this one also, copy. All right, so okay, so these are also initializing and running right now. Now let's have a look at their security group, Launch Wizard 1. All right, so what I'm going to do is I'm going to click on the security group and see what do we need from this rule of SSH. I'm going to open. Right now, all traffic is open. As such, HTTP is good. You can open from any IP address. SSH you can open from certain IP addresses which are actually useful. Only for certain IP addresses, all traffic can be opened. All right. So basically, what I'll do is I'll open SSH only from my IP and all traffic I can open. So I need to assign internal IPs to this. I can give a range of IPs. Are they having any range? So I can give these IP addresses here that it can be open to each other like 172.0.0. That scheme, we can even define a scheme. All right, so in custom scheme, I can define like which IP addresses should access this. So 172, 172.31, these IP addresses. All right, so one moment, let's check the scheme we use for. All right, so all traffic 7. All right, so right now let's use it, install it, and later I will be changing this. Let's install everything first. Okay. All right, so now on the main node, I'm on the main node here. All right, so this is my main node. So I already have created passwordless SSH. What is the next step? Next step is that we are going to install Ambari first on the main node, like which will be Ambari server, and then from that we are going to install other nodes and services of Hadoop cluster. We are going to launch the cluster using Ambari. Now, so let's go with HTTP 2.5, which is the earlier version. We can go with 2.6 also, but let's go with 2.5 for the time being. We are using Red Hat 7. All right, so uh, so basically I need Ambari repositories for Red Hat 7. So I'm going to use this base URL and get this repo installed locally first. So what I'm going to do is I'm going to do sudo wget and this repo. Well, wget is not yet installed here. I'm going to install it. Sudo yum install wget. Right, so all right, so wget has been installed. Now I'm going to get the Ambari repo here. So let's do it. Okay, so it came pretty fast. Ambari repo is saved here. Let's see. So Ambari.repo file has been saved here. Now I'm going to copy or move this file into the default location where yum repos directory is there. So let me just check ls etc yum dot. All right, so right now these are the different repos available here. I'm going to move this repo also to the same directory with sudo mv, and so this is the file name, right? And I'm going to move it to etc, right, to this location. So once I move it here, I can always refresh my repo list. So we can see that Ambari repo has already been moved there. Ambari 2.6.2.2 repository. Okay, so it's already moved here. All right, what else do we need? So now we got Ambari here. Let's install the Ambari server on this machine. All right, so I'm going to do that. I'm going to do that with a sudo. Having root privileges. All right, Ambari. So better to do everything with a sudo. Ambari server. All right. Sudo yum install Ambari server. Let us see. This should be the command. Yes. So it is going to ask me again same thing. So Ambari server bits are getting installed right now. Okay, so we are at this step. We are right now. All right, I moved it completely instead of copying. Ambari server setup, and then we need to set up the Ambari server. Says getting the keys from the public URL. All right, let it install. So basically, when we are installing an Ambari server here, which is getting installed on one particular node, and from that node we'll be spinning more nodes. So basically, Ambari UI will be opening on port 8080. That's the web UI of Ambari. All right, so. All right, so it's complete. So now I'm going to set up the Ambari server. All right, so sudo Ambari server setup. All right, I'll go with default values. I'll keep clicking default values. Okay, so basically you can check if you want to make any changes. For example, here we are going to use a JDK, which is basically Oracle JDK. Okay, you can use custom JDK if you have custom JDK in your machine. Do you accept binary agreement? We have we accept it for the Java. It is asking. So let it install this JDK from Oracle, most probably. No, it's downloading from, okay, the Hortonworks site. All right, enable Ambari server to download and install GPL licensed L0 packages, completing setup, configuring database. Do we want to get into advanced database? Ambari has got a database, PostgreSQL, so we can configure that ourselves a little bit with users and all, but Ambari has got default users. When we want to add any new user or anything, we can always go to that database and do that. But right now I'll go with default users, default permissions, everything. So you can see it says about to start PostgreSQL because it is right now configuring a local database for Ambari, which is PostgreSQL. It's creating schema, user, tables, everything is being done. So Ambari server setup completed successfully. Now we need to start our Ambari server, all right? So let's start our Ambari server. So on this node, I'm going to start my Ambari server. My two more nodes are also there, but my Ambari server is going to be on one of these nodes, which is the first one. We can have it on any node, but then we need to provide passwordless SSH to and fro to those nodes wherever we have, because Ambari server is going to install some Ambari agents when it is going to launch the cluster, and those Ambari agents have to register. Those hosts have to be registered. So there are no errors and warnings. So it's a good news. We got Ambari server installed. So as it says, Ambari server is listening on 8080. Now let's go and access our Ambari server. All right. So I will take this. I can take this also, HTTP this. I put it there and put 8080, and it is going to give me access because 8080 port I have opened for accessing from anywhere. We can also use HTTPS if you want. If we have a certificate, port is different, 8088 I suppose for that. No, it's not 8088. Something different we need to, but it's all right. So I'm going to, so let me save this as a favorite. Admin is the default password. You can always change that. You can change the users. You can add new users also using admin. Provide, give them different permissions. So you can see here different users, different user groups. So if I click on, all right. So right now no views. I was clicking on users, but so basically Ambari is again was an open source tool which has been packaged with HDP cluster installation. Here we can see the users. So right now admin is like one of the user. So we can create more users here and give them different kind of permissions. All right. We have different user groups here. Which can be created. So when we click here, so it will again take us to the first page, which will be like, it is asking us to launch a cluster. Okay. So it all depends upon the network speed. All right, so it takes me here, cluster. So it says, all right, give a cluster name. So I say my AWS, my HDP cluster. All right, so, or I'll call it Ashwin HDP cluster. Any name you can use. It doesn't take special characters, but like this. Okay, my HDP cluster. Now, as you remember that we can either take different versions of HDP are there. All right, so different versions are there. Based upon that, it is going to select a particular base URL or from public repo. Provide base URL for the OS you are configuring. So Suppose I want HDP 2.5.3.0, all right. So automatically it will pick a particular base URL. So here we have different services. We got Spark 2.00. Okay, that's a little old. So if I take 2.6.5.0, let's take this. Here we have Spark 2.3.0, which is latest. Let me take a little older. Yeah, this looks good. 2.2.0 and not very old. And I don't need this. Red Hat PPC 7. PPC 7 should be CentOS 7 PPC. We don't have that. One moment. So ours is not PPC. What's the difference? PPC versus 7. Let's see. All right, it's a different kind of version. I don't need to use this. All I'm gonna do is, so guys, let's do one more thing because on Red Hat 7 with 2.6, there are some issues. So I'm going to, let's do one thing. Right now, I'm going to install this, which is not having any issues. Okay, and so HDP 2.5, I'm not going to take this, not this. So mine is Red Hat 7. I'm going to use that. Let's see if it is a clean, straight installation or there are going to be any issues, then we are going to handle them. All right, so let me move to next step. In the next step, I need to provide hostname FQDNs. So I got 3 host names here. So I'm going to provide the internal IP addresses of these host names. Fully qualified domain name we need to provide like this. Okay. So you can also get host names from here, like, but we already have them from AWS console. I had already copied them here. Anytime you want to get, you forget where to get it from, it's pretty simple. You go here, you need to take the private DNS because, all right, so this one. Okay, so my second one is, so I can even copy these 3 in a row. I go to Ambari and copy another 2, 1 in a line. As they're saying 1 per line, you can have as many. If it is a 64 node cluster, you can just copy all 64 together. Now provide your SSH key. So again, to give browse from this path. This is my PEM file. So you can see that key is loaded here. Now SSH user account EC2 user will work here, not because that's account is, this key is for this particular account. All right, so let's move. First, it will be setting up Ambari agents on all host machines, including Ambari server, because Ambari agents are going to talk to Ambari server. There will be heartbeats. These are the agents which, while we are using management tool of Ambari like this tool, and we are seeing the cluster, and these agents tell the Ambari server that this particular node is down, this particular node is not working, this particular service is not working. So you can see that it is registering right now. So yeah, so our first node is already registered. Others also it's registering, should be a success on all. All right, so it has registered, it has installed Ambari agents and registered all three. Now it's checking if there are any potential problems on these hosts. So Ambari is a very user-friendly tool, suggestive tool. It tells you uh, on every step it is going to tell you what happened. And if you look at the logs properly, you can look at Ambari logs. So this is where my server is. Just a second, locate Ambari. So basically when we installed Ambari, what is the location of Ambari? That will be, one moment, somewhere USR. One moment, not yet. Let me just check the default Ambari location. So, default Ambari location on HDP Linux. Let me just check that. Okay, it looks like USR lib Ambari server. Let me see, but those are the library files. Let me just check USR lib. Yes, you got Ambari server here. So all Ambari server files are going to be here. So these are the Ambari server, but these are the jar files, library files of Ambari server. We are talking about different scripts of Ambari server. So we can figure out, it will be under user only. So it's going to be user bin. One moment. Bin, yes. No, this bin is basically no. So user local now. One moment. Locate star Ambari star. I'm just trying to locate. Locate is also not installed. Sudo yum install locate. Okay, it's not installed with this. There is another way of. All right, so I'll do that later. But user lib Ambari server. One moment, USR. Okay, these are JavaScript files of Ambari, like, but I'm not concerned about them. Okay, we can find that during the course of our this thing. But libraries of Ambari are actually available in lib file like this. And lib, under that there are other libs. These are different libraries which Ambari is using. Let me just check. So far current is not there. After HDP installation this will come. This is for HDP installation. Okay, no problem. So Ambari is installed, Ambari is running, Ambari has registered these nodes. There are no, it's all green. So If there are any issues, it says you can run this script, but there are no issues. We go to next. So one moment, I'm still not getting it. Where to get Ambari logs, right? So, all right, it is in var log, and just like so, ls var log. All right, so we can see here Ambari agent and Ambari server. So ls var log Ambari server. So these are Ambari logs, and so Ambari alerts, Ambari server log. This was what I was looking for. So as if there are any issues during installation, you can always check. So all this happened, and we can do tail -f and like that. So it says no clusters configured right now. So because cluster is not yet configured, so it is saying that. Now we reached up to the services we are going to install. So you can see that there's this whole list of Hadoop services which we can install here. All right. So I'm going to install HDFS for storage, Yarn for processing, Tej as an engine for Hadoop query processing on top of Yarn. Hive, I'm going to have my data warehouse, HBase at non-relational database, Pig, I can have Scoop, Uzi, Zookeeper, Falcon, I don't need. Storm, I don't need. Storm is again for stream processing. I'm going to use Kafka. Accumulo is not required for me. Atlas, I don't need right now for governance. I need Kafka. Nox is all right. Smart Sense is needed. Spark, old Spark, it is ticking. Spark 2.0 is fast in general engine. Spark, okay, here it is technical preview. I'm going to take it. So I'm going to have both Spark 1.6 and Spark 2.00. Now new versions are available in 2.20, 2.30 and SDP 2.6.3. So we can have a look at that. We will later install the latest versions. Mahout, I don't need. Slider is basically deploying, managing, and monitoring. More services we deploy, more time it's going to take and more resources. But distributed applications on Yarn. Let's keep Slider for the time being as such. Mahout, I don't need. Zeppelin notebook is good. It's a notebook for writing Scala code and other things. So this is the default setup it has given. So my, if I see 192, so basically it has main node. So it's using 192 is node 2. It's using node 3 as my, basically for installation purpose. It has chosen itself. You can always change that. So which one do we want to have name node on? So name node I would like to have, say, on 175. All right. So I decide where I want to have. So all these things, name node, HBase master, all these in Kafka broker. So Kafka brokers, you can even have more. All right. So let's see. I'm going to have one name node, and I'm going to have this on. All are same, dual core, 8 GB machines. So this is my 175. This is going to be my name node. All right. So 175. Secondary name node, I can move on the 192. Resource manager, is 175 only. That's good. And 175 history server 175, Hive Metastore 175, Hive server 2 175, HBase master again I am going to move to say 175. Kafka broker right now only one it is saying. Let me have a multi-node Kafka broker, all right. So that is also possible. Spark history server, Uzi server 175. So 175 is going to be a bit loaded, but we can keep servers different. Zookeeper, everywhere Zookeeper will be on all three nodes. Kafka broker is on 192, 175, and 242, all three. Spark history server, I'm going to again keep at 175. Spark 2 history server also at 175. 175 is going to be pretty much loaded right now. Let's keep it this way. Kafka, 3 Kafka brokers I'm going to have. So basically I'm going to have a Kafka cluster with multiple brokers, all right? So I'm having a broker list here. So I'm just showing you like how we can install multiple things. You can have 2 HBase masters. You can have multiple Kafka brokers for high availability, all right, fault tolerance. You can have more partitions. You can define number of partitions, could be more. So 3 Kafka brokers. Let's move to next. All 3 nodes will be data nodes. All 3 nodes will have node manager. All 3 will be region servers. All 3 will have Flume agents. And all will have clients. All right, so let's move on to next. I hope there are, first we'll get this installation. All right, so now there'll be some configuration of passwords for different services. So I'm going to give a normal password, like say root. Root is my password for everything, so that it's easy to remember. All right, so but in real scenarios, an administrator may prefer to keep different passwords for different services, because there'll be, for Derby, Z server is Derby. Generally, it's recommended we can use even a MySQL server with Uzi. So we need to have an existing server, and then we need to define the database URL and everything. For the timing, let's just, there are many configurable properties for every Hadoop service here. We are right now going with default properties. Later we can do tuning. Whenever we want, we can do little performance tuning. Nox master secret, all right. So Nox is again authentication service. Well, this used to come. So it's like if you get a support from Hortonworks, so you get this ID. I'm going to type something here. So root, for example. I don't know if some more are left. What are those? Yes, Activity Explorer is also going to have root. I think now all configuration are addressed, and let's go to next. And I'm going to save our deployment plan here. All right, it is already giving me node manager hosts with high memory usage found. Examples 192, 175, 242. Consider reducing the allocated memory containers. Okay. So it says that we have hosts with node managers with very high memory. So it says not to keep it that way, right? So you can always do that. So let's keep two data nodes, two node managers, one resource manager. All right. So uh, otherwise there could be a performance hit. That's what it means to say. So I'll just go back, assigning masters first. So this one I already assigned. All right. So okay, so we go to next. So client side, let's keep one thing. 175 is I'm not going to keep as node manager. So 175 I'm going to keep relatively free for clients. Flume agent can be there. All clients can be everywhere. But data node and node managers are only here. Or we can even have the clients we can have everywhere. Yeah. They can connect through data nodes or same node. All right, this is a problem, like everything needs to be done from scratch again. So show me properties with the issue. So I need to do this again. Next. Sorry, other properties are also there. All right. So let's be a little patient with this configuration. It's a huge configuration we are doing because it's a cluster, small cluster right now. We are doing with default values, but you think if you need to do with proper tuning and all, this sometimes take a couple of days, all right, to complete. I'm right now going with default configuration. We can always go to Ambari and change this configuration, means settings, memory allocation to node managers, resource manager, data node storage. So that's the job of a Hadoop administrator, all right. It's good to understand all these settings, even if you are a developer. If you want to become an architect, so still it says node manager host with high memory usage. So basically, all node managers, it says that allocated memory for containers. Basically, there is a combination here where it says that we have allocated on each node manager about 3 GB of memory. All right, so out of 8 GB I have moved here 3 GB. So let's proceed anyway, because right now we have taken less RAM because it's a paid service, and I'm just going to do this trial. Otherwise, a typical node of HDP, because it's commodity hardware, so that can have about 64 GB of RAM. So 3 GB is not going to be a big problem. Derby is not recommended for production use. It says Uzi server high availability will not be available, but we are not going for Uzi high availability right now. So we're going for standalone Uzi server, one Uzi server. So let's do it. So moving to next step. All right, so let me clear this. Let me increase brightness of my machine. It's full as such. All right, this is my installation, okay? So for HDFS, is data node is on 2 hosts. Secondary name node is on one of the hosts. So this is my installation, all right? So name node is on one of the hosts. All right, so I'm going to print this for any future reference if you want to know where is what. So it will be very difficult to track, or you need to come to Ambari and find out. So let me just save it. So my Ambari cluster install wizard, so you can give any name. My previous plan I'm going to replace. So we know where is our Uzi server. Even if you want to keep on different servers, better to keep this plan so that you know where are your servers, all right? Let's go and deploy it. Let's see if it gets deployed smoothly or it takes a while and it takes some more troubleshooting. All right, so basically this task is going to take a little longer time. You can have a coffee break also if you want, but it's good to monitor if there are any errors in between. Generally it should be smooth if everything is fine, all hosts are configured properly. So, and all permissions means all inbound outbound traffic permissions are given. So I've given all traffic to all right now, so I think should not be a problem. But still, so still deploying. Let's wait for this to deploy. It has started installation of different services. So it's all this should become green. So everything will be green when installation completes, all right? You can see in the background a lot of processes are going on. So this data node installation is going on. So this is trying to install this package of Hadoop. I hope it succeeds. Here it is installing data node again. So installing the Hadoop package. Here the first thing itself is installing Hadoop package. So basically it's doing a yum -y install Hadoop, and installation should not be a problem. So let's leave it here. So gentlemen, folks, we need to wait for some time. Ladies, gentlemen, folks, we need to wait for some time for this to complete. So let this process run in the background. In the meantime, I'll be giving a little overview of some of the things here, which is again a little theory, but very important, all right? So basically what is happening here is, we know Hadoop cluster, basically you can see, is a collection of nodes, all right? So there could be 64 nodes, 20, 32 nodes, 5 nodes. We are right now creating a cluster of 3 such nodes, all right? Each node is having disks, all right? So storage is there, and each node is having some memory, okay? So that's how it is. So this is a typical HDFS. So when we are installing name node, basically on one of the node, it is going to be name node. and say we are having these data nodes, like one data node is here, another data node is here. So what we are trying to do here is basically, and HDFS clients are going to be there. So HDFS clients basically, write directly to the data node when you are copying the data or you are putting the data. But whenever a client is going to do a read, it is basically definitely going to do a read from directly from data node. But name node keeps the metadata of the file. All right, so for the data which is basically divided in number of blocks, we'll come to that concept. So basically there is in HDFS there is a block size. For example, I got a file of 10 gigabytes. All right, so 10 GB file I have got, and I got say uh, a 3-node cluster. All right, so and I got whatever storage I'm having on each cluster, it's like 40 GB, 40 GB, 40 GB. So I got right now 120 GB of the storage. So for a 10 GB file to be stored, uh, Hadoop will not store it on one single data node. Like I'm using two of those nodes as data nodes, so about 80 GB of the storage I have. Hadoop is going to have blocks of this file, so it's going to break down this file in number of blocks of 128 MB default size, and then all these blocks are basically going to be stored in two data nodes. Had I got 5 data nodes, it's going to be on 5 data nodes, and replication factor by default is 3, but in this case, as there are only 2 data nodes, so automatically it is going to be replicated on both the data nodes. So every block is going to be on both the data nodes for high availability point of view. Fault tolerance, we can say, if one data node goes down, then still it is retrievable. All right, secondary name node is basically meant for it is again like just like name node, it is having everything as name node, but it is not exactly name node HA. It is not like in high availability, but it can sometimes it also contains the similar information like metadata. Metadata information on name node is basically name of different blocks, replicas of the blocks, what is going to be the block size, and what is the location of this data. So all this metadata is there. So this is how HDFS works. Let us now check. All right, we have moved ahead. So you can see so many green stuff here is good news. Data node installation completed, Flume installation completed, HBase client is installed, HBase region server is installed. We'll come to all these things like when we will be talking in depth about each and every technology. We'll be taking up separate tutorials for that. All right, so in my main course it's going to be like tutorial sessions on Hive, sessions on Scoop, sessions on HBase, sessions on Spark for batch processing, Spark for streaming, Kafka with Kafka and Flume. So different use cases we'll be taking, and that time we'll be going through that. So this installation is going to take a while. So it is even installing, you can see a MySQL server, basically for Hive Metastore. It is installing the MySQL server by default. So I think our today's work is going to be completed with this installation. So it's installing name node, Uzi clients here. So all this will come in the log of Ambari, and can even tail that log. So this is the Ambari log. Let's see if I can tail this. Let us see. Let's see what does it give. So yeah. So you can see like all these things are getting installed. All right. So you can. So like that, you can tail the log and you can log file and you can find out what has been installed and what is not. So, all right. So gentlemen, I think For today's tutorial, I'm going to now end this session, because this installation is going to be complete, everything is going to be green, and next time we are going to use the same say cluster for our next session. All right, so thanks a lot for listening to this, and I hope you will be trying this out. And also, if you have AWS account, you can try this out. For a single standalone cluster, you can use HDP Sandbox, but to get a feel of a cluster, better to go on AWS and do this, because there will be multiple nodes and multiple services on different nodes. All right, so or different clients, different servers, like Hive Metastore, Hive server, Kafka brokers you need to install in a cluster, like multiple brokers, Flume, multiple agents, like that. So HDFS, multiple data nodes, node manager, multiple node managers for Yarn. So you can do that. All right, so I'm going to stop the recording now.